All right, in this lesson, we're going to continue on the process of solving equations. There's some review information about solving equations. We've got the addition property being used in this example and a little check. We've got the multiplication property being used in this one and a little check. We're going to use both of those properties as we did in our last lesson. Here is a reminder of the steps for solving equations. Remember that this is chapter 4, so we really have 1, 2, 3, 4, 5 potential steps. If you don't have those written down yet, you might want to do so. I'm going to go into the examples. I'm not going to do all of these because their last video was very long and we don't need them to be quite that long. All right, problem number 1. We're just going to jump in here. I have 7x plus 52 is equal to 2x minus 13. Barrier. Step 1. Can you simplify on the left-hand side? No. No distributive property, no like terms. Can you simplify on the right-hand side? No. No distributive property, no like terms. Second step, are there variable terms on both sides? Yes. You need to eliminate one of them. I'm going to get rid of the smaller one. It's a positive 2x, so I'm going to subtract 2x using my underneath shorthand notation. 7x minus 2x leaves you with 5x on the left. Bring down your plus 52. Equal sign. Those cancel out, and you're left with negative 13. Don't forget its sign when you bring it down. Variables on the left, focus over here. Is there a constant to get rid of? Yes. And I will do the opposite, which is subtract 52, subtract 52. I have 5x, those are gone, equals negative, negative, using the addition rules. If they're both negative, add them up for negative 65. What do we call the 5 that's with the x? It's its coefficient. It's multiplied by it, so we'll divide by it. That leaves me with x is equal to negative 13. All right, next one, I have 24 minus 5x is equal to 18 plus x. Can I simplify on the left? No. Can I simplify on the right? No. Are there variable terms on both sides? Yes. Now, this one over here has an implied coefficient of a 1, a positive 1. This one has a coefficient of negative 5. If I follow my guideline of getting rid of the smaller, negatives are always smaller than positives. So, although it's not a formal rule, I'm going to add 5x to eliminate that, which means I have to add 5x over here. That gives me 24, those are gone, is equal to, bring down the 18, positive 1 and positive 5x gives me positive 6x. All right, so all of my attention now is focused over here and things look a little different. Is there a constant on this right-hand side? Yes, it's the 18. It's usually written behind the variable term, but it's in front this time. It's a positive 18. So I'll subtract 18 and subtract 18. 24 minus 18 gives me 6 on the left. Those cancel out, and I have 6x left. Still looking over here, I'm going to divide by 6, because that's the coefficient right there, and I get 1 is equal to x. All right, let's skip down to number 4. Like I said, I'm not going to do every one of these problems in this video. So I'll copy down my problem. As it looks more complicated, usually all that means is you've got to simplify. On the left, can I simplify? Yes. I don't have distributive property, but I do have like terms. They're just separated. The coefficient of that x is a 1. So 1x and 2x gives me 3x plus 17. There, I've simplified the left side. Now the right side. Are there any other x terms? No, so I'll just write down the minus 2x. But constants, I have two of them, negative 11 and negative 17. That gives me negative 28. So I simplified on the left, combining like variables. I simplified on the right, combining like constants. Simplifying's over. Do you have x's on both sides? Yes. I'm going to get rid of the smaller, and we've decided that negatives are smaller than positives, so I'm going to add 2x, which means I have to add 2x over here. That gives me 5x plus 17 is equal to negative 28. Focused on the side with the variable, is there a constant to get rid of? Yes. I will subtract 17. That leaves me with 5x, 17's are gone, equals, those are both negatives, using the addition rules, add them up for negative 45. Now 5 is the coefficient of the variable, so I will divide by it. You never divide till it's the last step. And that leaves me with x is equal to, whoops, creative division there. How about just, whoop, where'd it go? Oh, look at that 9. That's quite some 9. Negative 9. Sorry about that little craziness. Okay. Looking at this one, I have 24 plus 5y minus 4 is equal to 17y minus 12 minus 4y. Can I simplify on the left? Yes. There's some like terms, but I'm going to write down my 5y first because it's customary to have the variables come first. Then 24 minus 20 gives me positive 20. On the right-hand side, I have some like variables. I have a positive 17y and a negative 4y for 13y minus 12. Okay, so I've simplified on the left, combining constants. I've simplified on the right, combining variables. Do I have y's on both sides? Yes. I choose to get rid of the smaller one, so I'm going to subtract 5y. That gives me 20 is equal to, I'm going to have 8y minus 12. I'm going to give all my attention over here to the right-hand side because that's where the y is. I'm going to add 12 to both sides. Positive 20 and positive 12 gives me 32 is equal to 8y, and those have canceled out. Divide by the coefficient, which is 8. 4 is equal to y. And I don't usually write that in red. So now it's very colorful. All right, I want to do number 6. Looks like a really simple problem. It doesn't have a whole lot to it, but it does have a very unique characteristic. I have 4 minus b is equal to 16. So I'm going to put a little curly Q around that because I really want you to pay attention to it. How could something so small be so important? Well, can you simplify on the left? No. Can you simplify on the right? No. Do you have letter B on both sides? No. Okay, so all my attention is over here. Is there a constant number over here to get rid of? Yes, there's a 4. What's the sign of the 4? It's a positive 4. I know there's a minus there, but that belongs to the B. So that's a positive 4. I'm going to subtract 4. Positive 4 and negative 4, those cancel. Now, this is what gets overlooked. That's negative b is equal to 16 minus 4 is 12. The problem is not over yet. It doesn't say, whoops, b equals. it says negative b equals. So what's the coefficient? There's no constant. We took care of it already. The coefficient there is an implied -1. So I'm going to divide by -1. That means negative divided by negative is +1b is equal to -12. Your problem's not done when it says negative b equals. It's done when it says b equals. I think I'm going to skip all the way to the last problem because there's nothing really new in those others. It's good practice, but I don't think you need more examples. May not need this one. All right, can you simplify on the left? No. Can you simplify on the right? No. Do you have variables on both sides? Yes, you do. -2y, +5y. I choose to get rid of the -2y, so I'm going to add 2y to both sides. That leaves me with -10 is equal to 5y plus 2y is 7y plus 18. Focusing your attention over here, is there a constant to get rid of? Yes. I'm going to subtract 18 from both sides. Remember, you're using your addition rules. Negative and a negative, add them up for -28 is equal to 7y, and those are gone. Now I'm going to divide by the coefficient of the variable, which is 7, and I end up with -4 is equal to y. Okay, lots more examples. I hope you're feeling pretty good about solving equations now.